Good afternoon, everybody. I'm Abby Bronson from PPMD, and I'm delighted to be able to introduce this afternoon's, actually morning's, webinar on Summit's compound azithromycin and their plans for it. Before I introduce our speakers, I want to let you know that we will have time for questions at the end of the talk. So if you have a question or you need more clarity on something, submit your questions in the chat box, and we'll try to answer as many as we have time for. And at the afterwards, if we don't get to answer all the questions, so you can certainly answer them by email. So we will get to all of them. As Kaylin said, this webinar is being recorded, so you'll be able to access it at a later date. And now it's my pleasure to introduce our speakers from Summit. We have three of them: Michelle Avery, Ralf Rosskamp, and John Tinsley. Michelle joined Summit in 2015 and heads up their patient and family relations role there. Ralf Rosskamp joined Summit as Chief Medical Officer in 2015. He is a trained pediatrician, and in his previous role at NPS Pharmaceuticals, he oversaw the development of several rare disease drugs. John Tinsley joined Summit in 2005 and serves as Chief Scientific Officer for DMD. He previously worked in the laboratory of Professor Kay Davies and has published widely on Utrophin and Utrophin Modulation. He also discovered azithromycin. So now, Michelle, I'll pass it over to you.
Thank you, Abby. First, I'd just like to thank PPMD for hosting us today, and also thank you to all of you who are able to join as we discuss our approach in DMD that's quite unique, called Utrophin Modulation, that has the potential to treat all patients with DMD. So first, since we are a public company, I do have to show this legal disclaimer, just saying that we will be making forward-looking statements, but thankfully I do not have to read it to all of you, so we'll move on. So Summit is seeking to treat all boys and young men with Duchenne using our Utrophin modulation. We're a small company headquartered over in the UK, in a small town outside of Oxford called Abingdon, but we also have a US office here in Cambridge, Massachusetts, where Ralf and I are sitting. And so many of you are familiar with Utrophin modulation as an approach that has the potential to treat all patients with DMD. And John will actually be going through this approach a little bit more after I'm done with this introduction. So he is our resident expert on the topic. As Abby mentioned, he did work in the lab of Professor Kay Davis, who pioneered this approach and also discovered Utrophin. Importantly, Utrophin modulation has the potential to be complementary to all other approaches to DMD. And finally, our program here, you know, we're basing this work on that of Kay and John's, of advancing a pipeline of Utrophin modulators. And our most advanced treatment to date is azithromycin, which is in a phase 2 clinical trial called PhaseOut DMD. And so first we'll have John chat about the Utrophin biology and also Utrophin modulation. And then Ralf will give a brief overview of PhaseOut DMD and azithromycin. And finally, John will speak again about the work that we're doing on biomarkers, which has the potential to help us track the effect of Utrophin modulation in patients with DMD. And so now I'll turn it over to John. John?
Thank you, Michelle. Okay, so what I want to go through here is a bit about the biology of Utrophin and a bit about the biology of Dystrophin and how the two proteins can actually perform the same function. So the slide that you can see here has a simplistic view of muscle. So muscles made up of fibers, which are then encased in a matrix, and they make these bundles up, and then numbers of these bundles make the muscle up. But each fiber, one of the easiest ways of thinking what dystrophin and utrophin are doing is if you think the fibers are like a trampoline, as you can see on the left-hand side here. So what you have is you have the mat, which is like the inside of the muscle. You have the outside of the frame of the trampoline, which is essentially the muscle membrane. And then the trampoline is stabilized by these springs, which keep the whole thing together. And that's essentially what dystrophin and utrophin are doing. They are the the intracellular shock absorbers for fibers to allow them to contract and to be extended without essentially tearing themselves apart. And as with a trampoline, as you start to take these springs away, then the muscle fibre becomes less stable until when there's not enough of the springs present, you will then start to damage the fibres and they will have to start trying to repair themselves. So the bottom part of this slide is a diagrammatical way of trying to show you how similar dystrophin and utrophin are. So each of those shapes that you can see is actually, it's not just being randomly picked, but it's actually a way of describing a certain protein function. And what you can see is if you overlay dystrophin with all these different protein functions, and you do the same for utrophin, you can see that very simplistically they are very similar proteins and they have very similar functions as these molecular shock absorbers in muscle. So I'll say where the differences then occur between dystrophin and utrophin. So if we've got two proteins which have a very similar function, where is it that they differ? And it's the main difference is the time that they're expressed in muscle development. So utrophin is present in the very early developing muscle in the fetus. At this time, it's only utrophin which is allowing the fibres to grow and protect them from damage. And over time, there's a switch such that the utrophin protein gradually reduces and the amount of dystrophin protein that's going to bind to the membrane increases. And so before birth and as the fibre and the muscle matures, it's all dystrophin that's now found as these springs, as the molecular shock absorbers of the fibre. However, even in this adult muscle, you still find utrophin expressed at very special places. So even in muscle, adult muscle, there's natural times when this utrophin is always being expressed, and this is around where the nerves join onto the muscle and where the muscle joins to the tendons. And so the figure you can see here is really trying to show you early development here. You can see utrophins are being expressed. These are essentially the red dots. And like I say, these bind to very specific sites, like the springs. And as the fibre matures, you start to turn off utrophin. So it's like a tap. You can turn the tap off, and so the amount of utrophin reduces. And you turn the dystrophin tap on, so it gradually starts to replace utrophin at these sites. And so by the time the fibre has matured, it's all dystrophin that's really along the length of the fibres. The other important place where utrophin is found is in regenerating fibres. So regenerating fibre is essentially a fibre that is being repaired. So that a damage has occurred to the membrane. The fibre is then goes through a repairing process where it removes the damaged piece. You get new cells being synthesized, which then link the fibre together, and a repair patch is made. And this is all done with utrophin. So around the repair, this regeneration is all protected and stabilized by utrophin. And then in the repair patch, you get the utrophin tap being turned off and the dystrophin tap turned on. So again, you eventually have a completely dystrophin profile. Now what happens in DMD? So the DMD boys, they all have fully functional utrophin. So their muscle, very, very early on in development, has had utrophin. As time has gone on, the utrophin has been turned off. However, there is no dystrophin to start to occupy these sites. And as I said, the utrophin tap is turned off. And so that there is no dystrophin here. And so the fibre, because of no dystrophin, is damaged and starts to regenerate, so it starts to repair itself. And that's what it should do. So all the boys have this natural repairing process for their muscle. But because of the normal control of utrophin, it's been turned off. So what we're proposing for what we're calling utrophin modulation is a way of trying to stop the tap from being turned off. So even though you're getting the repair process and the fibres are maturing, the small molecule drugs that we're developing, which you take orally, are able to stop this tap from being turned off. So the tap continues to generate utrophin, so you still have utrophin along the length of these fibers, even with no dystrophin. And it's this now a replacement of dystrophin with utrophin in the Duchenne boys, where we hope that we will now be able to stabilize these membranes from further damage. And when you stabilize these membranes, then that's when over time you start to see a reduction in the pathology and an increase in muscle function. So what we know naturally, as I've said, and this is just to show it experimentally, is that you find high amounts of utrophin in DMD. And this is because the snapshot of where the cut through the biopsy has lots of regenerating fibers in. So here in non-DMD muscle, these lines here, so this is using an antibody against dystrophin, so it can localize exactly where dystrophin is. You can see dystrophin is around the membrane of all of these fibers. And as I said, in non-DMD muscle, utrophin is expressed, but it's not expressed like dystrophin is all over the place. So occasionally you see regions of utrophin, such as here, and this is an area where the nerve is contacting the muscle, and this is utrophin is found quite localized around here. And DMD muscle, as you know, there is no dystrophin present, so there's nothing marking the fibers. But you can see there's a relatively large numbers of these fibers are trying to repair themselves. And as I said, during this repair process, this is where you now find utrophin. But if you could follow this fiber here over time, what you would see is gradually the utrophin levels would fall till there's no protein here anymore because the tap's been turned off, and because there's now no utrophin or dystrophin on this fiber, it would then go back into its repairing cycle, and this would be the case for all of these fibers. So how have we shown this? We've developed a Utrophin, and so one of the things we want to be able to do is to show that in the animal models for DMD, and in this case it's using the dystrophin deficient MDX mouse. Again, you can see what we've shown you for the DMD patients. So in this dystrophin deficient mouse, and these are two different kinds of muscle, you can see this patchy expression of utrophin at the membrane, and that's because these fibers are ones which are regenerating. If you give this mouse the Utrophin for a few weeks and then look at the amount of utrophin you can see, what you now find is that essentially all of these fibers now are utrophin positive. So Utrophin has been able to keep the utrophin tap turned on in these fibers such that it now has the chance to replace dystrophin and stabilize these fibers. So in these mice over time, these dystrophin-deficient mice over time, you will now start to see a reduction in the pathology and see increases in muscle function in these mice. So that gives a brief overview of the relationship between utrophin and dystrophin and what we're looking for these utrophin modulators to do, which is to maintain the expression of utrophin protein at the membrane of the fibers in DMD boys. So I'll now hand over to Ralf to talk more about the clinical work.
Thank you, John. First of all, I want to thank all the patient organizations who have supported us throughout our development here at Summit. Without their help, we would not be here where we are now. Big thanks to all the patient organizations. Utrophin has been in development for many years and has previously been studied in a total of 4 studies, both in healthy volunteers and in patients with Duchenne's muscular dystrophy. The main purpose of these earlier studies was to find a safe dose which could stimulate the utrophin production in muscle tissue. This work was successfully completed and enabled us to start our PhaseOut DMD proof of concept study, and I will talk about this trial a little later. We expect to report 6 months biopsy data from the first patients of this trial by the second or third quarter of this year. Last year, we also entered into an exclusive license and collaboration agreement with Sarepta Therapeutics, which gives Sarepta the right to Summit's Utrophin pipeline in Europe, Turkey, and some former Soviet Union countries. In return, we receive certain milestone payments, and it gives us access to the deep insight and knowledge of Sarepta in running clinical trials in DMD. PhaseOut DMD is a one-year open-label study, which means that there is no placebo group, and we will compare each patient's data at 1 year with his baseline data. We will enroll approximately 40 patients, and enrollment is well underway. Patients have to be between their 5th and 10th birthday, which makes it very unlikely that any of these patients lose ambulation during the study and then could no more perform some of the functional tests which are required in this study. The enrollment in the UK is complete, and as I said, we are right now finishing up enrollment in the US. Within this study, we are looking at a range of mechanistic and efficacy endpoints. All boys are receiving 2 biopsies, one before drug treatment, and then another one either at 6 or 12 months. In these biopsies, we want to look whether we now can see utrophin localized across the entire fiber and whether the amount of muscle fiber regeneration is reduced, similar to the pictures which John has shown you in the diseased mice. We are also studying the effect of izutrophin on the composition of the muscle tissue using magnetic resonance imaging, or MRI. This technique allows to determine whether izutrophin can stop the relentless replacement of muscle tissue with fat or connective tissue. And of course, we are measuring all the other functional tests like 6-minute walk distance or North Star assessment, which have been used in previous DMD trials. The next 2 slides show you the location of our 8 US sites and our 7 UK sites. And with that, I turn the mic over to John again.
Okay, thank you, Ralf. So I'm just going to spend a few minutes now talking about the development of biomarkers. So these are markers which hopefully will tell us that muscle is getting better after treatment with izutrophin. And as you know, as Ralf just said, is that we're interested in taking muscle biopsies so that we can really look in depth at the muscle fibers themselves to see if we can see appropriate changes which are suggestive of utrophin modulation because of taking izutrophin. So one of the first things I want to say before we even get into the technology of what we're trying to do is to say that we understand how precious these muscle biopsies are because of the efforts that families and the boys have to go through for them to be taken. So what we've been very careful to do is to develop a very well-regulated methods to provide high-quality samples from the biopsies from the boys. And so for all the sites, we've generated special manuals to tell them exactly what to do. We have training visits and calls with all the people involved in taking the muscle biopsies. We have videos to help show them what they're supposed to do. And also, we've been very careful to select specialist transportation couriers who are used to transporting very sensitive patient material. So we've put a lot of effort and time into trying to make sure that we have the best chances possible that when we want to look at these biopsies, they'll all be of very high quality to allow us to do this. So moving on to what we're going to try and show is what we're trying to do is develop new tools to do this, and what we're looking for are things that are completely automated, so that people don't have to give their opinions of looking at these sections. So it's all automated and done by machines, essentially, which means that the reproducibility and the accuracy of the data we generate is far better than people looking at these sections. So we want to do it for utrophin protein. I've described how repairing muscle makes utrophin, and what we want to see with the study is that we start making utrophin which has come from the drug, rather than the utrophin that's hanging around because the muscles are trying to repair themselves. So we're looking to be able to quantify the actual amount of utrophin that's sitting on the membrane, and also very importantly, we want to know that it's not just a little bit of utrophin that's stuck on one piece of the membrane. For us to be able to stabilize the fibers, we really need utrophin all the way around it. So we're developing technologies which will allow us to do that, so to quantify utrophin intensity from fibers which have utrophin all the way around the membrane. And then muscle maturity is very important, because this is actually, the more mature fibers you have means that the less damage has been taking place. And a good marker for damaged fibers is a protein which is found in muscle, which is called developmental myosin. And this is only expressed in fibers which either are regenerating or have recently regenerated. And over time, just like the utrophin tap is turned off, this myosin tap is turned off. So fibers which don't express developmental myosin means they're not regenerating, they're not damaged. So if that number falls over time after taking Utrophin, it means that your muscle is becoming less damaged. And so briefly, I'll try and go through what we're doing and how we're trying to develop these technologies. So the first thing is you get receipt of high quality muscle biopsies from the sites. We then cut them, so we're cutting across. So you're now looking down on the fibers now. So it's like looking down on lots of discs, where each disc is a fiber. And we're looking at thousands of these fibers. So it's not just we're not looking at just a few fibers. We're looking at thousands of fibers from these biopsies. And what we want to be able to do is, with these technologies, show that they're sensitive enough to see differences in utrophin and differences in regeneration and fibers. So for that, we needed a range of different samples to do that. So we had non-DMD control muscle, so we can look at how utrophin is normally expressed and what regeneration levels are normally in non-DMD muscle. We have a range of DMD muscle biopsies, which is, some of them are severe and some of them are more moderate. And also we have Becker patient biopsies, so these are the patients who make lower levels of semi-functional dystrophin, and so now you can have pathology ranges in muscle from severe and moderate and mild. So we have this whole spectrum now of different disease pathologies, and we can now look to see how do these automated systems quantify across this range of diseases. And so what we need something to tell the software where all the fibers are, and this is what laminin alpha 2 is. This is a marker of the membrane, so here you can see all the membranes are being stained by laminin, so the software knows exactly where all the fibers are. It's not going to try and count anything in between them. We obviously want to be able to stain for utrophin, so this is an example of utrophin from a DMD patient. Lots of regeneration, so lots of utrophin. Beta-dystroglycan is a marker of other pieces that are important to be found in the membrane, so we can do that as well. And here's the regeneration marker, so the marker of damage. This is this embryonic or developmental myosin. And here you can see these strongly staining small fibers. So these are recently regenerating fibers. And here you can see some slightly larger fibers with less intense staining. So these fibers are still in the process of regenerating, but they're starting to mature, and the myosin tap is being turned off. So we have the pieces that we need to be able to do these studies, so let's see what they look like. So this is an example of the regeneration quantification. So this is quantifying the amount of developmental myosin that is in a whole section. So here is a sample from a Duchenne boy who has a moderate pathology. So this is the whole of his section of the biopsy. All the blue bits here have been assigned to be Utrophin negative, regeneration negative. You can see some yellows and oranges. And this is all because of the staining that we have. So here is actually the biopsy section stained with the two antibodies. So you can see all the fibers. This is the sort of orangey stain. And wherever myosin is, this is the blue stain. The smaller, more recently regenerating fibers are a much more intense color. As the fibers become less regenerative, then they become more and more pale. And you can quantify all this very simply. So here is the recently regenerating one, which is stained very dark blue, being pseudo-colored orange, and then we have the next level of red, then next level of orange and yellow, and then no staining. So you can see with this, you can now start to quantify the amount of regeneration or the amount of damage that is taking place in this individual biopsy. And this is just another example of the Becker patients where we know that because of the dystrophin, they tend to have less disease pathology, and that's exactly what this section shows. You can see here there's significantly more blue fibers, so these are negative fibers, and then there's little clusters of regeneration taking place. And again, if you zoom in to see the actual antibody staining here and how it looks when it's been pseudo-colored, again you see you have little clusters of regeneration because these fibers are being protected to some extent by dystrophin. And so if you do this for the whole range of different disease severities, different pathologies going from severe down to moderate to mild and to even non-DMD, what we find is that there's a good correlation. So in the more severe pathologies, so the Duchenne's, what you find, and so these are just examples of some Duchenne biopsies here, where this pale is essentially no regeneration and then some regeneration, more regeneration, and a lot of myosin. You can see that most of the Duchenne's have a lot of myosin present because of the amount of regeneration that's going on. But in these Becker patients who have a lot less damage because of the presence of some dystrophin, it's quite easy to see with this technology that actually they also have less regeneration. So what we're envisaging, one possible outcome from the study is that you change the pathology after your Utrophin treatment, so you reduce the amount of regeneration from something which has a profile like this to something which more has a profile like that. And the profile like this says there's less regeneration. If there's less regeneration, then the muscle potentially will be able to function better. I now want to go into Utrophin briefly. So this is a section from a DMD biopsy. Again, a similar pattern of staining, but here there's very few blue fibers. So there's very few fibers here which are Utrophin negative. And you see this massive range of Utrophin expression taking place here. And this is because of, in this biopsy, because there's no dystrophin, then most of these fibers are going through this attempts to keep repairing themselves. So this system is very good at being able to identify fibers which are Utrophin positive. And here's a Becker patient, as I said before, because they have some dystrophin, then they have less regeneration. If they've got less regeneration, then there's less Utrophin about. So again, you can see that there's foci of damage around here on the muscle, but there's lots of areas where there's no repair taking place, so there's no Utrophin being expressed here. So the systems work really nicely, that we can really accurately quantify the amount of Utrophin protein at the membrane and how much Utrophin goes around the membrane, because that's very important, and also be able to show how much regeneration there is. So finally, this is just really showing you how, when we look at the antibody staining, again, we have the orangey around the edge, so this is identifying all the fibers, and the blue here is the utrophin around the membrane. And again, the pseudo coloring of this, again, makes it very easy for the software to count utrophin, identify the utrophin fibers and count the amount of utrophin and how much of it goes around the membrane. So my final slide really is trying to give you to help understand what we might see with the Zutramid treatment and modulating utrophin in dystrophin deficient muscle. So what I've tried to show you is in normal muscle, these are developmental myosin are essentially negative. There's no regeneration going on. And the amount of utrophin that's present in all these fibers is low to zero, unless you happen to be near the nerve terminal. What I've shown you for DMD is that both the amount of developmental myosin in fibers is high, and also the amount of utrophin that you find in these fibers is high. And one possible outcome we will see with Zutramid treatment is we'll shift the staining profile of fibers. So where you start to see more fibers which have negative or low amounts of myosin, so saying that these fibers aren't regenerating, but they're still making utrophin. So for a fiber to be making utrophin but not to be regenerating really means that this is not what you see in normal biology. This really has to be because of the Zutramid treatment is now driving the continued expression of utrophin to the membrane and protecting these fibers such there's less regeneration. And so what I hope we've shown here, and obviously can take questions on it, is the very sophisticated ways that we're trying to treat these biopsies, these precious biopsies, to be able to understand if we can see almost at the source, so showing that utrophin modulation is taking place in these fibers and is protecting these fibers.
Thank you, John. And so that is the end of our prepared slides. Just first of all, again, just wanted to thank you all for joining us for this portion. We will now take questions. But before that, if you have want to find out any more information on our PhaseOut DMD clinical trial, you can look at clinicaltrials.gov, which also has some contact information for the site. And further, we have a patient and family dedicated website at utrophintrials.com that has a lot more information on the trial, and also a sign up for periodic news and updates from us.
Thank you, Summit. That was great, all of you guys. This is Abby. So there are a few questions that have come in, and I also have a few questions of my own. First of all, I make a bet everyone's wondering when you talked about, in one of your slides, you talked about the arrangement with Sarepta and that they licensed the product to some Eastern European countries. Can you talk about what that really means, like, for the patient community? I mean, what does that really mean for them?
Sure. So I'll go ahead and answer this question. So, the agreement with Sarepta is really for the marketing of the drug. So if it should get approved, they will take over marketing in Europe. But until then, we will be working together, getting expertise from them on the clinical trials and their regulatory interactions and all that sort of good stuff to help us out along the way. But we, as Summit, will be conducting all the trials in Europe, U.S., and wherever else in the world that the trials should take us.
Okay. And so you described the PhaseOut DMD trial, and that the baseline or the biopsies are supposed to be reported sometime in 2017. And then if it's successful, like, what's your next step? You finish this PhaseOut DMD trial. This is an open label trial, and then what would you next do?
Yes, the next step then would be to conduct a double-blind placebo-controlled trial, and we don't have any details for this at this point, but we believe that the regulatory agencies in both in Europe and the U.S. would require such a study under an accelerated or conditional approval pathway, similar to what Sarepta's approval was based on an accelerated approval pathway, so that you still would have to show in a confirmatory trial establish the clinical efficacy, but that you can conduct such a study using a surrogate endpoint, like, for instance, the Utrophin Modulation, which John was alluding to, or what we're doing right now in the PhaseOut DMD trial, the MRI endpoint.
That's great. That's exciting. So, so we got a couple questions, and one is about the. This person is saying the Summit trial is scheduled for later this year, and wondering for, I guess, inclusion criteria. Can you be on steroids if you are in the Summit trial?
Yeah, we have not fleshed out the details of what our next trial would look like in terms of an exclusion criteria. And as you would expect, there would also be a discussion, again, with the regulatory agencies in the U.S. and Europe. Generally speaking, for our ongoing study, patients have to be on a stable dose of steroids for 6 months. And I would assume that something like this would also be within our next protocol, without knowing any details at this point.
And if vamorolone or if the catabasis product, I mean, I don't know if the time you look up, but if those other anti-inflammatory NF-kappa B inhibitor products got improved, would that count, or would that not count as a stable dose of steroids? Probably not.
Again, we would have to look at the details, what actually these drugs would contribute to the effect. You have to think in such a confirmatory or such an accelerated approval trial, you want to show primarily the effect of your drug. If it's used in standard of care, the standard of care, for instance, are steroids, yes, the standard of care drugs will be used, and but in terms of combination with other drugs, you have to be careful that your effect doesn't get confounded by the effect from another drug. So therefore, mostly in these first clinical trials, you focus on the effect of your drug, and then in later clinical trials, you see how drugs work in combination with each other.
Okay. We have another question about the protocol and the fact that there's some foods that are prohibited from a patient consuming while on the trial. Can you explain that a little bit?
Yes, the drug Utrophin is heavily metabolized through the liver, through certain enzymes in the liver. And there are certain fruits, or there are drugs, or there are vegetables who actually stimulate the production of these enzymes and could interfere with the metabolism of the drug. Since this is our first trial where we study Utrophin over a longer period of time, we have been very careful to eliminate any possible interactions with other drugs or with vegetables or with fruits, because again, we want to study the effect of only Utrophin and not have any potential interaction with other compounds. That's why we are excluding some of these vegetables.
Right, and so I understand that, and I understand the need for that, but to just, I think, give the community a little bit more information. I mean, is there, because you can't monitor your kid every single second of the day, like if they're going to school or they're at a friend's house. I mean, if someone accidentally ingests one of those things that you're not supposed to ingest, I mean, is it an adverse event? Is it, or it's just from a study result standpoint that it's?
If somebody does, and I understand that something like this could happen, and the kid isn't always 100% under the supervision of his or her parents. If the parents get to know, they should let the physician know at their next visit that on this occasion, and then the physician will ask, so did you feel differently? He will look at the lab values. Is anything changing here? So the physician will make the determination.
Okay. But it's not like a safety concern or anything.
There is no direct safety concern. But there is always, of course, the potential of an interaction, but that's why you do the clinical trial, and that's why you try to gather this information, and hopefully gathering this information in this trial will allow us in our next trial to be a little more liberal in these requirements.
Okay. And another question about, our biopsies are a necessary evil, I guess you could say. So, there's obviously a concern about taking just as little as possible. So what size of a biopsy are you taking? Because it's obviously you don't want to take any more than you have to.
John, would you like to answer this one?
Yeah, so currently the biopsy pieces that are being taken, they are large. They're about, ideally about 0.5 centimeter in diameter. So, as I say, we can get these several thousand fibers, which allows us to do detailed work and accurate work, and then they need to be a little bit longer so we can cut sections through them. And we're taking them from the biceps. But I will say that actually DMD muscle still is very regenerative, and so actually it can, repair itself quite effectively, as you can see from the activity that's going on. So we understand that it's something that ideally you wouldn't do, but I think the understanding that we can get about the drug and how it's working and how we can see the benefit to muscle itself means at the moment it's an important part of our studies, and we understand how precious these samples are, and we're doing everything we can to make sure that every sample is received in perfect condition so that we can do this analysis.
And is there any work, I know the biomarker work you're doing is pretty exciting, but that's still based on biopsies. Is there, I don't know what you're thinking about going forward, but is there any way to get get the information from the biomarkers, but not from a biopsy?
So certainly we are interested in the kinds of biomarkers that you could see in blood, for instance. and we will look to see if there are changes in those, but we don't really understand, and I don't think anybody really understands what changes you might see. So the importance of the biopsy is really, this is what we would call target engagement. This says that if you've taken this drug, it truly is affecting the muscle that you want it to affect, and it truly is reducing the amount of damage that's taking place in that muscle. And that gives us huge amounts of confidence that all the other endpoints that we start to look at over time should also start to potentially change in the right direction, as it were. So at the moment, it's very important, for the next this study and probably the next studies. So
hopefully
down the line.
Down the line. We're working
down the line. But I'd just like to reiterate that, we're not wanting to, we internally have had a lot of thought about the pros and cons of the biopsies, and it did come down to really that if we want to understand and get some evidence that we really are modulating utrophin, then the biopsy is the way that we can do this.
Mm-hmm. Okay. Are Becker patients included in the study?
No. This is a study only in male DMD patients.
And someone asked, the UK study, I guess that's where you started PhaseOut DMD, that started a while ago. Is there any preliminary readout, or is the first readout going to be with the biopsy data later this year?
Yes. The first readout will be with the biopsy data in later of this year.
Okay. And is there an extension study to the PhaseOut DMD?
We have, we have a plan to have an extension phase. The decision is currently in process, and we hope that we will be able to communicate this in the next couple of months, that we will be able to extend this trial beyond 1 year.
And importantly, we're aiming to make that decision so that the patients who began on the study would not have a break between treatment.
Okay, that's great. So I know that we had a question earlier, this is before the webinar, about why the limitation to age 10, and I think that you answered that really well. I mean, you have an you want to make sure that the patients, the participants, can still complete all the functional tests that they have to. But in going forward, do you expect to expand the age at some point into older boys or slightly older boys?
Well, as I said, we haven't made any final considerations what the next trial would look like. There will be a lot of discussion, both with regulatory agencies, with patient organizations, with the treating physicians. What I can say, though, is that such a program, even with a next phase study, you will always look also at other groups who cannot be included in this trial. Certain registration studies, you always try to clearly define your group and not spread yourself too widely in terms of patient characteristics. But having said this, for instance, we know that before you do such a trial in Europe, for instance, you have to commit to trials in younger patients, which you are not studying. And it is well within the general plan that we will also study patients outside of the range within our next study.
Okay. And how many slots are available in the UK? Slots are all filled, right? And how many patients is that?
Yeah, so we have the total number of patients is up to 40. It's roughly half and half between the two, but we can't give further guidance to that.
Okay. Okay. Let's see. You have another question. So I have a question and then a follow-on question. So first of all, you refer to this as Utrophin Modulation versus upregulation. Can you talk about why you use that choice of words?
Yeah, certainly. So the reason that we talk about modulation versus upregulation is that we're looking to change the timing in which utrophin is present. So we're not actually creating excess amounts of utrophin. We're just keeping it on the entire time that the muscle is functioning. And so that's kind of why we call it modulation. We also want to make sure that when we're looking for results, we're not necessarily looking for an increase in the amount of utrophin. As John nicely explained, there is a lot of utrophin in patients with DMD already, but it's only at points where the muscle is regenerating, but it's still going to be pretty high. So we could have a steady state of utrophin where we have mature muscle, all with utrophin, that actually has the same amount, less, or it could be more utrophin than boys at baseline. So that's why we refer to it more as modulation versus upregulation.
Okay. And then there's a question, are any other proteins turned on as a consequence of upregulation? They said, but I think it's modulation. You might have sort of already answered the question, but...
John, would you like to answer that one?
So, nobody really knows what happens when you take a drug. There's many other things that may be affected. So we've done the normal things you're supposed to do. So one of the things is, you imagine if you're changing lots of other proteins, that may have some sort of toxic or effect or some safety effect. So what we know for azutramid, when it's tested in all these long-term animal studies, that there's never been any evidence of toxicity or safety, even with very, very high doses. So if it is changing any proteins, none of them show any kind of bad effects because of that. And also, as you know, you can treat cells and look at the RNA profiles of all the genes that are in cells or tissue. And we have done that. And what you see is there are some changes. There's no obvious pathway that's related to, cancer or anything like that that's changed. So I think the whole data set that we've got that really shows that azutramid and whatever it does, because we don't know the mechanism, we know that it keeps utrophin going, but whatever that mechanism is safe.
Okay. Let's see. There's some questions. So. No, some I think you're just not going to be able to answer. What's the administration and the timing? Is it daily? Is it twice a day? And
yeah, it's been given twice a day right now as an oral suspension in the morning and in the evening.
Okay. And here's something about, you have MRI as one of the outcome measures, and the age of the patient is, some of them are pretty young. Have you had any experience, or have there been any issues with trying to get those young patients to do an MRI?
No, we are working together with the Imaging DMD group out of Florida, who has actually pioneered this for DMD boys, and they have certain centers in the U.S. And in the UK who can do this investigation, and they have very skilled operators who talk to the boys, who explain it. The boys usually have a video above the scanner, which they can watch. They position the leg in the right way. They have, if needed, the mother present. So actually, when we were recently at Imaging DMD, they were telling us they were doing imaging even with younger than 5 years old. So it's all a matter of the right person doing the investigation. So we so far haven't had any challenges here.
Okay. Yeah, that's what I've heard too about imaging in young patients, that the video is key. What if a DMD patient, here's a question, what if a DMD patient has some dystrophin in the muscle? Would they be excluded?
Well, usually a DMD patient doesn't have dystrophin, so usually the amount of dystrophin is zero. So our inclusion criteria right now say that if you either have a recognized genotype, so you did the genetic analysis and you have DMD, or you have absence of dystrophin in the muscle. So if somebody has some dystrophin left in the muscle, couldn't participate in the study, but I don't know, John, whether you want to add something to this.
No, I think that's right. I think to my mind, if you have dystrophin, then you're not a classic Duchenne, and so the genetics and the dystrophin negative biopsy, or one or both of those is what's needed.
Okay.
Beckers are an interesting group in their own right, and down the line, you could imagine that actually Utrophin and some dystrophin could also be beneficial to that group of patients. So, again, that's something we're thinking about.
What about herbal supplements are an exclusion criteria in your trial? Is there a washout period that's permitted? Like beforehand, can you stop for a certain amount of time and then come back?
Yes, for all these supplements or drugs which are not allowed, there's always a washout period. It depends what the so-called half-life of the drug is, so how long does it take until the drug is totally eliminated. It's usually, so as a rule of thumb, around 3 weeks. Most of any of the supplements or drugs are no more present in the bloodstream, and then no more prohibitive for the study.
Okay. Can we go back to the slide with actually I might have the slide with the sites, the U.S. sites, if that's possible? Can I do it? Let's see.
Yes, we're pulling it up right now.
Okay. There's so you stated, I think you said that the enrollment is almost complete in the U.S., and then I think you said you can't really make any comments in it. So, I mean, I think there's some people ask, and also people want to know if you can add more sites to the U.S., and when you expect it to be completed. But I'm not sure you can answer these questions.
Yeah, so right now we do have those 8 sites that are open, and all of these are listed as recruiting on clinicaltrials.gov in our record there. There is the potential for maybe 1 or 2 more sites to come on, but right now we're focusing on these 8 sites, and unfortunately we can't give guidance as to our enrollment.
Okay. All right. Well, I think we've gone through all the questions. I want to thank you very, very much for the time that you spent with us today and for describing your program and describing your product. And it sounds really exciting, and we'll all be looking forward to hearing about the readouts later this year. So thank you very much.
Yes, and thank you, Abby. And any questions we did not get to, we'll be happy to answer afterwards.
Okay, we'll keep monitoring that, and I'll send them to you probably tomorrow, and then we can post them on our site.
All right, thank you, Al.
Okay, great. Thank you.
Thank you.